Math 3, Unit 4, Graphing Rational Equations. Okay, so rational equation, rational comes from ratio. Ratio means fraction. It means you have a variable in the denominator of your fraction. So we're going to start with graphing the parent function. When you have 1 over x, and you're just plugging x into the denominator, so you can figure these out pretty easily. Just 1 over negative 2 is negative 1/2. 1 over negative 1 is negative 1. 1 over 0, you can't have 0 in the denominator, so it's undefined. It's going to be an asymptote there. 1 over 1 is 1, and 1 over 2 is 1/2, and these go on. And you can look at them in your table, or you can just look at it in your calculator. What you've got here are 2 asymptotes. We have a horizontal asymptote, which happens here because you can't plug anything into your denominator here to get 0. So you're never actually going to reach 0. Your horizontal asymptote is the function y equals 0. Your vertical asymptote is right here where your x is 0 and it's undefined because you can't have 0 in your denominator. So that's going to be x equals 0. And you're going to graph these asymptotes whenever you're graphing your equation. And I'm going to graph my points. I have 1, 1, and then it's going to look like this on both sides. I have 1, negative 1. Harder to show because my other points are so small and so close to the asymptote. Rational equations are just like fractions. They can be proper, improper, or neither. So this is going to be huge when it comes to graphing variations of rational equations. If it is proper, then that means the degree of the numerator is less than the degree of the denominator. So you have x over x squared. You can have other things too, but you're just looking at your leading terms. Or you have phi, which would be x to the 0 over x to the first. Or x squared over x to the fourth, something like that. Those are proper. That means you have a horizontal asymptote at y equals 0 always for proper functions. When it's improper, that means that the degree of the numerator is greater than the degree of the denominator. That means there's no horizontal asymptote, there's an oblique asymptote. It's also called a slant. It's linear, but not horizontal or vertical. And you have to do division to find the oblique asymptote. So examples of this are when you have x squared over x, or x to the 5th over x to the 4th, or x over 1, but that one is just a normal linear equation. And then neither is when the degree of the denominator and numerator are equal. So this we have 2x over 4x here overall. Your x's have the same degree, so your horizontal asymptote is the ratio of leading coefficients. Sorry. So I have y equals 2 over 4, which is 1/2. That's going to be my asymptote here. Here, because that's my leading coefficients. Here, I would have y equals 2, because 6 divided by 3 is 2. These would be my horizontal asymptotes for each of those equations. So the steps are listed here, but I'm going to go through them with you. You always want to simplify your fraction first. It's going to be your first step. That means factoring and putting it in factored form. So this bottom part, the top part, I cannot do anything with. It's just 1. The bottom part, I'm going to take a 3 out, my GCF, and I have x squared plus x minus 6. Then I'm going to factor this as much as I can. What I want is to get to a bunch of binomials. Remember, that's 2 terms with an x and a constant. So factors of 6, that can give me 1, 1 and 6, 2 and 3. To get positive 1, I'm going to have positive 3 and negative 2. So I have 3 times x minus 2 times x plus 3. That's my denominator. So that's going to be your simplified form. Your factored as much as possible form. Your zeros. This is what happens when your numerator equals 0. Well, my numerator is 1. 1 never equals 0, so there are no zeros. These are x-intercepts, roots, things like that. Vertical asymptotes happens when your denominator equals 0. So I can use my simplified form here and set it equal to 0. Use the zero product property to solve each piece. So 3 is never equal to 0, so there's not one there. Here I'm going to add 2, so I have x equals 2. And here I'll subtract 3, so I have x equals negative 3. So So my vertical asymptotes happen at 2 and -3. Horizontal asymptotes, this comes down to whether it's proper, improper, or neither. My degree of my numerator is 0 because I don't have a variable there. My degree of my denominator is 2 because that has x squared as the biggest one. So the degree of the numerator is less than the degree of the denominator, which makes it proper. And all proper ones have a horizontal asymptote at y equals 0. Holes happen when you can cancel out terms when simplifying. We haven't canceled anything out, so this is not applicable. And my y-intercept is, you can either set x equal to 0 or it's the ratio of your constants when it's in like your original form, your standard form here. So my y-intercept is actually going to be 1 because that's my constant over top over -18. You can also plug this into your calculator and look at where x equals 0. So in my calculator now, to graph this, I'm going to plug in my equation. And you're more than welcome to use your calculator to help with all of this and seeing it and remembering it. All right, I have my asymptote at -3 and at +2. I have my horizontal asymptote at 0. My y-intercept looks like it's really close to 0 there, so that would make sense. There are no zeros, x-intercepts, because it's got asymptotes there. So you can look at your table to kind of verify these things. At 2, you have an error for your asymptote. You should have an error again at -3. And you can see that everything's getting closer and closer to 0 all the way around that. So I'm going to look at my graph to help me, and I'm going to fill out everything I've got. So I've got an asymptote at 2. What I'm doing is the least that I expect to see. Asymptote at -3. Horizontal asymptote at y equals 0 because it was proper. And my y-intercept is really close to 0 at 1 over -18. So then I've got this, it's getting really close. It's not quite a parabola. It doesn't have to be perfect. And then here, this one's also really close. You can find some exact points on your table. These are kind of hard to point because none of them, they all just get closer and closer to 0 so quickly. So this one, what we've got there is good. Next one. We have x minus 2 over x minus 4. We don't have to factor anything there. That is our simplified form. There's nothing we can do to simplify it. Zeros is where your numerator equals 0. So I have x minus 2 equals 0. Add your 2. And you get x equals +2. A 0 is an x-intercept, so there's a point there. Vertical asymptotes is where your denominator equals 0. So set that equal to 0 and solve. Add your 4, and you get x equals 4. So that's a vertical asymptote at x equals 4. Horizontal asymptotes. This one is neither because my degrees on my top and on the bottom are both 1. They're the same. So that means I have an asymptote at the ratio of my leading coefficients. So my leading coefficient is 1 over 1, which is 1. My holes, nothing canceled out, so that is not applicable. My y-intercept is the ratio of my constants, which in this case is -2 over -4, or 1/2. So I have a y-intercept of +1/2. Right here. So now I'm going to type it in on my calculator. So I have x minus 2 divided by x minus 4. The parentheses are necessary. And there you go. You can get some other points if you want. You can see your error there at your asymptote, which is 4. I have the 0.53. I have the 0.62. Everything else is just going to be more difficult to graph. I have the point 3, negative 1, and that helps me get this picture. That's it. This one, we have some factoring to do. So my top portion, I have x cubed, so minus x squared minus 6x, so I can take an x out of that, and I'm left with x squared because they all have an x. You always have to start with your GCF. Minus x minus 6. Now I want my factors of 6 to add or subtract to give me 1, 1 and 6, 2 and 3. To get negative 1, I need negative 3 and positive 2. So my numerator, I have x times x plus 2 times x minus 3. My denominator, I'm going to pull a negative 3 out first, and I'm just showing a little work over here. Negative 3, and I'm left with x squared plus x minus 6. Now I've got my factors of 6 here that I need to add up to give me positive 1. So I'm going to use 2 and 3 again, but to get positive 1, I have positive 3 and negative 2. I'll have negative 3 out front. I'll have x plus 3 and x minus 2. Now, so this is my simplified form because nothing cancels out. That is it. My zeros are going to be where that numerator equals 0. So I'm going to take each piece and set it equal to 0. I have x equals 0, x plus 2 equals 0, and x minus 3 equals 0. So I get x equals 0, negative 2, and 3. These are my x-intercepts. My vertical asymptotes are where my denominator equals 0. So I have negative 3 equals 0, x plus 3 equals 0, and x minus 2 equals 0. Negative 3 is never 0, so there's nothing I can do there. I get x equals negative 3 and 2 for my vertical asymptote. My horizontal asymptotes, this one is improper because the degree of my numerator is x cubed and the degree of my denominator is x squared. So I have to do some long division when I have an x cubed over an x squared to find my oblique asymptote. So to do my long division, I have x cubed minus x squared minus 6x. And on the outside, I've got negative 3x squared minus 3x plus 18. Now, I want to know what I can multiply negative 3 by to make it 1. So I know I'm going to have an x because I have my x squared to make it x cubed is x. But I need to know what to make it. So I'm going to say x cubed, not in the calculator, x cubed divided by this here will give me that. So I can always say this term, which is going to be x cubed, I'm going to go over here and write it, x cubed divided by my negative 3x squared. If I simplify that, that gives me what goes here. So I get my x cubed and my x squared cancel, and I'm left with just x on top. And then I have that negative 3 on the bottom. So what I have is negative 1/3 x, or negative x over 3. Then I distribute this back through, so I have x cubed here, negative 1/3 times negative 3, you can plug it in your calculator if you're not sure, is 1. So I have 1x squared, so plus x squared. And negative 1/3 times negative 18 is negative 6x. Now I have to subtract, so those cancel. I get negative 2x squared, and those cancel. So now I need to do the same thing. I'm going to say this guy divided by that guy. So negative 2x squared divided by negative 3x squared. My x squareds cancel, my negatives cancel, and I get 2/3. So my equation, all I need is this part, this linear part up here, is going to be y equals this. Whatever this guy is going to be my oblique asymptote. That long division is going to be the hardest part, but it's not that bad if you follow the steps. My holes, nothing canceled out. And my y-intercept, I have 0 as my constant on the top. You can add that plus 0 if you need to. 0 over 18, which is just 0, which I've already got plotted here. So now I'm going to graph this equation. because this is my asymptote, it's important to graph it. You do need to see where it's at. I graph it as a dashed line. So when you have something like this with all of these fractions, just type it in your calculator. Look at your table and you'll get a couple of whole number values. So I have 2, 0, so that's going to be a point. I have -1, -1, so now I'm just going to make a dashed line through these points. -1, +1, I'm sorry. -1, +1, 2, 0, 5, -1. So now I can just kind of use my slope if I need to. 8, -2, like this. Go back up. -4, 2, -7, 3, -10, 4. So this is my oblique asymptote. And now I'm going to graph my equation. I'm going to leave that in there so that you can see how it works. I'm going to graph my equation. I always go back and graph my original just to verify that I did everything right, because I might have messed up whenever I factored. So that is my asymptote, my oblique asymptote. And look at my pretty function. Look at how it just goes right along my asymptote. Oh, I just love it. All right. So now I'm just going to graph everything based on what I've already got here. It's getting closer and closer to both of these sides on this side. Same here, it touches that x-intercept there. And then we've got the same thing here. All right, and then the last one, again, I'm going to factor. We just factored one like this, so on top I'm going to have x plus 3 and x minus 2. That was this bottom part here. Factors of 6, that give me 1, a positive 3, and negative 2. On the bottom, I'm going to pull out my negative 4. I'm left with x squared plus 4x plus 3. I need factors of 3 that will give me 4. So that's going to be 3 and 1. To get positive 4, I need positive 3 and positive 1. So on the bottom, I'm going to have negative 4 times x plus 3 times x plus 1. Now this time, these x plus 3's cancel out. So my simplified form is x minus 2 over negative 4 times x plus 1. You're always going to use your simplified form when you're answering all these questions. Your simplified form is what you need. Zeros are your simplified numerator. So I have x minus 2 equals 0 or x equals 2. So I only have the 2 there. Not the x plus 3, just the simplified form. Vertical asymptote, same thing. Negative 4 equals 0 and x plus 1 equals 0. Anytime you have that constant out front, you can just kind of ignore it. Because 0 divided by anything except for 0 is 0. I get x equals negative 1 for a vertical asymptote. Horizontal asymptotes, this is neither. So my asymptote is the ratio of my leading coefficients. So y equals negative 1 over 4. My leading coefficient there is 1. So you can look back at your original, or you can look at your simplified form. Either way for that one. So negative 1/4 is going to be real close to the 0 there. My holes, this is what happens when they cancel out. So if I canceled out that x plus 3 term, so at x plus 3 equals 0 or at x equals negative 3, I have a hole, and I'll show you how to graph that in a second. My y-intercept, my ratio of my constants, if you FOIL this back out, it works the same, but if you don't FOIL it out, you won't get it right. So you can look back at your original for this. Y equals negative 6 over negative 12, or 1/2. Plugging it into my calculator. Again, I'm plugging in my original x squared plus x minus 6 divided by negative 4x squared minus 16x minus 12. And there we go. So now the hole is not going to show up on your calculator because it's not very accurate. It's still pixelated. You have, you can look at your table though. And at -3, you have that error. That's because you have 0 over 0. 0 is not just on the denominator, which makes an asymptote. When it's on both, it makes a place that just doesn't exist. So I've got my asymptote at -1, and I've got all my points there. So I'm going to graph this guy. And when I get to -3, I'm just going to make a hole. So you need to make it look like you know what's there. So at -3, which is this x value here, it looks like I am going to be real close to there. Just have your hole. That's how we denote that. And that's it.